Hello everyone. In this video, we are going to talk about Chapter 12, Section 12.3, Kinematics of a Particle. We are going to look at lots of graphs today, including ST graph, position versus time, VT graph, velocity versus time, AT plot, acceleration versus time, also velocity versus position, VS, and acceleration versus position, AS diagram as well. We know that graphing is a very useful visual tool for us to understand what's going on. You will be dealing with lots of data, whether the data is provided to you or you collected the data. However, the data that you got there, it doesn't really mean anything until you put them on the graph. Graph provides a good way to handle the complicated problems into give us a visual description, visual understanding of what's going on with the physical quantities. Here is a diagram. First one right here is a diagram of ST diagram. It's position versus time. If we are going to plot the slope of the position versus time, so in other words, the first diagram over here, it's position versus time, right? Every single one of the point here that's connecting this blue line together, every single one of the point here, if I want to find the slope at that point, plotting all the slope together, putting all the slope together, that will give me the VT diagram, velocity versus time. Okay, that will give me, so in other words, the second diagram, VT, it's plotting the slope of the first diagram. Similarly, if I have the VT diagram and if I want to plot the slope of the line that's tangent to the velocity curve, that will give me acceleration versus time. It will give me the AT diagram. Keep going. The AT graph, given acceleration versus time AT curve, and then the change in velocity during a period of time is the area under the curve. So if I have this area under the curve, um, calculating the area under the curve doing the integral, we can, from the AT diagram, we can go backwards. Integral, that will give me the velocity versus time, VT diagram. Okay. As also, if I have AS diagram, acceleration versus position, AS diagram given, and if I want to do an integral plotting the area under the curve, this will give me velocity versus distance. Okay. VS, if I have the VS, taking the integral, that will give me the AS. So over here, by reading the velocity at the point on the curve and multiply by the slope of the curve, dvds, at the same point, we can obtain the acceleration at the point. And remember, we derived this formula in our previous video, so we can from the obtain the AS plot from the VS curve. Now let's take a look at examples, some examples more specifically. This right here gives us the velocity versus time graph. Velocity versus time graph. We can see that from 0 second to 5 second, we have velocity going straight up. And then from the 5 second to the 15 second, velocity comes down. Okay, from the VT diagram, we're going to need to find the AT diagram. So in other words, we're going to need to find the acceleration. Acceleration will be the slope. Okay, this line seems to be a straight line. From 0 to 5 is straight, it's a straight line. From 5 to 15 is a straight line. So that means from 0 to 5, I got constant acceleration. From 5 to 15, I got another constant acceleration. From 0 to 5, velocity increases. I have increasing velocity. The slope of this line from 0 to 5, which will be 30, that will be the acceleration of the velocity at that moment, from 0 to 5, from 0 second to 5 second. And then from 5 to 15, the slope, a negative slope, meaning my velocity is coming down. I have a decreasing velocity. I'm hitting the brake constantly, constant acceleration. Okay, so the slope of the first portion, 30, that's the slope of the first portion from 0 to 5 second. Slope is 30. That will be 30 horizontal line. It's a constant acceleration from 0 to 5 second. And then also constant acceleration from 5 to 15. From 5 to 15, I am slowing down constantly with a constant acceleration. The slope of that line is negative 15. the slope of the first line from 0 to 5 is 30. There we plot at 30. And slope of the line going from 5 to 15 is negative 15. I'm plotting negative 15 from 5 to 15. So there from the velocity versus time plot, I have the acceleration versus time plot. Okay. And also mathematically over here, where we're doing it mathematically, derivative of 30t with respect to time, that gives me 30 meters per second squared is the unit. Derivative of negative 15t plus 225, that will give me only the slope, right? Negative 15, that will be the acceleration from 5 second to the 15 second. And then if I need to look for, next thing we need to look for the ST graph. So in other words, how much distance does it travel? We know that going from 0 to 5, we're going to break that into two portions, 0 to 5 second, 5 to 15 second, okay? 0 to 5 second, we're going to calculate the area under the curve. 5 to 15 second, we're going to calculate the area under the curve again. Taking the integral, breaking that into two parts, 0 to 5 seconds and 5 to 15 seconds. So this one over here, the second one should be 5 to 15 seconds over here. That should be 5 to 15 seconds. And then overall, we can calculate the total distances to travel when we plug in the values 0 to 5 and 5 to 15. Next problem right here, we have a VT graph. VT graph is given to us. We're going to, from the VT graph, we're going to find the AT graph, okay? Find the acceleration of what's going on in this graph and also the average speed, distance traveled from 0 to 80 seconds. We're going to break it into two parts, okay? 0 to 40 seconds is part one, and then 40 to 80 seconds is part two. So in our part one, we know that acceleration is going to be 0. The reason your acceleration is 0 because from 0 to 40, 0 to 40 is constant speed, constant velocity, velocity no change. As from the definition of the acceleration measures the change of velocity over a period of time. So over here, velocity has no change. No change on the velocity means acceleration equal to 0. 0 to 40 seconds, acceleration equal to 0. 0 acceleration. 0 to 40 second, look, acceleration equal to 0. Second part, from 40 to 80, I am slowing down. My velocity starting with 40 meters, 10 meters per second at 40 second, and then coming down all the way to 0. I am slowing down. And again, constantly slowing down, constant acceleration from 40 second to 80 second. The slope there, which is which will be the acceleration of the from 40 to 80. Okay, so now we're going to look for the slope. Okay, you have negative 10 over 40, rise over run. It's coming down. It will have a negative slope, and this negative 0.25 meters per second square. Okay, rise over run. How much rise? Rise, we have 10, and then run. So rise, you have negative 10 because we're coming down, and then you run, you have 40, negative 10 over 40. That gives me the acceleration from 40 to 80. And then keep going. Next thing, we're going to look for the average distance, average speed. Okay, average speed. Before we go to the average speed, we're going to need the total distance travel. We need total distance travel divided by the total time. That will give the average speed. Total distance travel, again, we're going to break it into two parts. 0 to 40 seconds, part one. And then 40 seconds to 80 seconds, part two. 0 to 40 second, we know that it's constant velocity. Velocity, no change. It's simply just velocity multiplied by time. That gives me total of 400 meters. And then from 40 to 80, from 40 to 80, area under the curve, you can do the integral, right? Do the integral, putting the line for that velocity there, or you can just do the area under the curve. You're calculating the area of the triangle, you get 200 meters. Either way, it will give you the same thing. Now adding these two together, 400 meters plus 200 meters, that gives me 600 meters. Total distance will be 600 meters, and then divided by the total time. It took the vehicle 80 seconds total to complete this 600 meters. And then so the total average velocity will be 7.5 meters per second. Okay, so that is the total distance and the average velocity. Next one, velocity versus time graph is given to us. In this one, you can see that we're going to break into three parts. Part one, part two. Part 1, 0 to 4 seconds, velocity increases, constant acceleration. Part 2, 4 second to 10 second, constant velocity, acceleration equal to 0. And then part 3, 10 seconds to 15 seconds, I have negative acceleration, velocity coming down to a 0. Okay, we're going to plot that AT graph. Okay, AT graph will be the slope. First portion slope is 1.25 coming up. Second portion from 4 to 10 seconds, you have a 0 slope, you have a 0. And then lastly, you have -1 on the slope, which last portion from 10 seconds to the 15 seconds, the acceleration will be a -1. There's your AT graph. And then we're going to also look for the total distance travel. That will be the area under the curve. Okay, so again, acceleration, 3 parts. First part going up, positive acceleration, 1.25. Second part, 0 acceleration, because it's a flat line, velocity, no change. And then last part, you have a negative acceleration because I have decreasing on the velocity. The slope of that line is -1. Look right here, it says -t plus 15. The slope is -1. So there is my slope for the 3 portion. And then next thing, if we're looking for the distance total, that will be the area under the curve. Again, 3 parts. Part 1, triangle. Okay, triangle part 1. Part 2 is a rectangle. Part 3 is another triangle. Area under the curve, we're taking the integral, 3 different parts, right? Because we got 3 different functions here. First part going from 0 to 4 seconds. Second part from 4 to 10 seconds. And then lastly, it's from 10 to 15 seconds. Overall, you have 52.2 meters together. Okay, that's all I want to share with you in this video. Thank you for watching.